This is a conversation with Vince Gaydarzhiev, who is the president and founder of Alcatraz AI. Alcatraz AI uses biometrics, such as facial recognition, to help organizations with access control. This is useful for example, large companies who want to make sure that unknown people don't enter their buildings and steal their intellectual property. I found this conversation interesting because Alcatraz AI is using AI, specifically neural networks, in a situation where they need to make sure that their system behaves correct. False positives mean letting someone who is not supposed to have access in, and false negatives mean denying someone who has access their access, which could be frustrating and time consuming. In the past, I have seen government or medical groups turn down neural networks for more classical approaches in spite of their better performance on testing data. As I understand, they turn down neural networks because of their lack of transparency and the possibility that they interpolate novel inputs wildly, creating unexpected behavior. It is interesting to hear how Alcatraz AI is using neural networks reliably. Another hard problem we discuss is how Alcatraz AI seeks to use their past data to train their neural networks for new hardware. I think if you're interested in how AI is used in real applications, its benefits and challenges, you'll really enjoy this conversation. I'm Audrow Nash. This is the Sense Think Act podcast. Thank you to our founding sponsor, Open Robotics. And now, here's my conversation with Vince Gaydarzhiev. Hi, Vince. Would you introduce yourself?
Hi, Audrow. Nice to meet you. My name is Vince. I am the founder of Alcatraz AI. Alcatraz AI does physical access control with heavy AI and computer vision. And me personally, just quickly, I'm coming from NVIDIA and Apple as an engineer. And in the last 6 years, I've been working on a few products. The first one came last year. With the essence to significantly improve security while decreasing friction in large corporations and government through security.
Mm-hmm. So, how did you come upon the problem of physical access control?
Yeah, funny story. I never thought I would be in security. Uh, Many years ago, I joined Apple, all the way back when um, uh, the second, third generations of iPads were introduced to market. And in Apple, there are a few things that are going on. You can develop horizontally technologies, and vertically you can develop actual products based on those technologies, like iPhones, iPads, MacBooks. Horizontally, there are many technologies that are being developed. You've heard of
And by
Touch ID,
horizontally, you mean like technologies that apply to several
to many
products as
products,
opposed to
exactly.
specific products. Okay,
Exactly. So
the
for example,
verticals are
Touch ID,
specific.
exactly. So for
Mm-hmm.
example, Touch ID, it can be applied, on the MacBook, on the iPhone,
Mm-hmm.
on the iPad. And similarly, Face ID is one of those technologies. I
Mm-hmm.
got involved very early in the development of Face ID, all the way back in 2014. And eventually it came out on iPhone 10. So the idea behind Alcatraz kind of originated there. We were prototyping that project. We saw how amazing authentication would be on mobile. Basically,
Mm-hmm.
the whole idea was to be very passive but very secure in the backend. People should not realize what they're doing. My grandpa, he just turned 96 a few days ago.
Wow.
He has an
Yeah.
iPhone with Face ID. He doesn't know he's authenticated. He's just swiping up. He doesn't know what's going on, but it always works for him. Um, so how do you create this magical technology that's so passive and sitting in the background that no one knows that they're using some kind of technology, but it just works.
Mm-hmm.
And in the same time, I traveled around a lot of factories at Apple. Before Apple, I used to work at NVIDIA on chips that went into cars. So I traveled around a lot of car companies. The Probably many of the ones you've heard of, including Tesla. We helped to build the factory in Fremont that came up with the
Cool.
original Model S's. And physical security was always a pain. It was something that was stuck a little bit in the past with badges everywhere. People wear badges, people use badges to open doors. But if you want a little bit more security, since badges are intrinsically not secure, then you need a guard.
Why?
Uh,
Why are they not intrinsically
why not
secure?
secure? Well, you can give a badge to someone else, and I can badge
Okay.
it for you. I can lose my badge. Someone else can pick it up and use it. Badges can be copied very easily from 3, 4, 5, 6 feet away. So if
Huh.
you want to be
How
a
does
bad
that
actor,
work?
you can just hang out. There is a
So,
there are many devices that you can buy even on Amazon for $50 that will scan the frequency of the batch reader, and as soon as the batch shows up on the batch reader, it will pick up the batch number.
oh.
Especially up to recent years, the most used protocol for batch number output was something called Regent, which is non-encrypted, not secure. You can listen to it very easily, and it's really easy to get a batch number, copy it to another batch, and then just use that batch to get into spaces. So how do you
Mm.
enforce something like, how do you know whether the owner of the badge is the actual owner, the one that should be using the badge? Well, you need to have something more. And many companies that need security and that can afford security, they either put a turnstile, those revolving gates, but that's not really scalable. Usually those are put in a lobby or the main location, not on every single door.
What
But
does
companies who can,
so it's literally a revolving gate, so people have a one-way entrance kind of thing, or and only one
one
person
way.
fits at a time, or what's the point
Exactly.
of it?
Yes. Yeah.
Ah,
The point of it is just like in many lobbies, there is a gate with a barrier. One person goes through it as they badge in, and usually there is a guard that
ah.
does manual facial recognition. So basically, as soon as you scan your badge, your employee picture will show up on their display. They're gonna match it with your actual face, and if it matches, they're gonna, not make a big deal. You're gonna go through. But
Hmm.
imagine those guards looking at thousands of pictures and employees daily.
Oh yeah.
They're gonna have some misses. Even you and I, we kind of look alike. If I grow a little bit my beard, we're gonna
Yeah.
put some glasses. We're gonna be the same person
Mm.
to a guard. But to a facial recognition algorithm, especially a robust one, we're gonna be very different people.
Mm.
Yeah, so a lot of companies that need more security, including NVIDIA, especially Apple, they just put a guard on many doors, asking people to badge in, not only to prove who you are when you're going in, but if the door is open as soon as you badged in, what about the person behind? The door is usually open for 5 to 10 seconds as it's closing, automatically. How do you know if someone else didn't go through? You need to have
Hmm.
a turnstile or a guard to enforce this.
Mm.
So how do you solve this scalably? You really can't. A lot of the old ways was to just deploy a biometric, like a fingerprint scanner or a hand gesture scanner, that gives you more security. Essentially, it's really hard to spoof a finger. It's not impossible, but it's harder to spoof a finger or a hand versus a badge card. But that doesn't solve for the issue of, well, I can let someone else behind. I can scan my fingerprint and 3 people can get in through the same door,
Mm.
just because the other two
Followed.
didn't authenticate with intent, or maybe without any
Mm.
intent, right? So how do you solve for this? How do you create a technology, a flow that authenticates everyone who's going through passively? You should not need any intent,
Hmm.
but also very
What do you
securely
mean
and very
intent?
accurately. Intent is if I'm going through a door and I have access, I know I have access and I'm going through, but someone behind me tries to tailgate, tries to
Mm.
piggyback.
So they basically try to
Usually,
go in
if
right
they
after you go in
right
to
after me while the door is open, right? So
okay.
they may have access. They just may unintentionally not badge in because the door is open.
Hmm.
Or they may not have access. They may be a bad actor going into a company to steal IP, right?
Yep.
They'll definitely not going to authenticate in any way. They'll just try to
Hmm.
tailgate, right? So how do you create technology that scans the environment, tries to authenticate everyone who's going in, and it's so accurate to know uh, who the ones that are in, that should belong inside, and the ones that are going in that don't belong, and then notify security, or the technology should do something to make sure those people are recognized, and then you can
Mm-hmm.
follow different steps on catching the tailgater,
Okay.
independent whether that person has access or not. Right. So usually, before Alcatraz, such technology didn't exist. You can have different kind of tailgating technologies. Essentially, to dumb them down, very similar to a garage door sensor. When the garage door closes, and if you trip
Yeah.
on it, it will stop closing. It most likely will start going up again, so it doesn't trap, a cat or a baby or whatever. Same
Mm-hmm.
idea when you put such a tailgating sensor by the door, it will just count people based on, to go a little more technical, based on usually an infrared signal coming one way
Yeah.
to the other way of the door.
So it
And
has
if it
an
detects one
emitter and a
badging,
receiver, and anything that goes through it, it kind of counts the
is
occlusions.
one, right? So
And
you
how does it work?
you
I have two
badge in.
legs for that. You have like a time delay kind of thing, or
There
what's
is some
the?
kind of a time delay, maybe not the sensors may be larger with multiple emitters towards the body and the legs,
Ah,
kind of
okay.
self calibrate.
Yep.
But essentially, it doesn't know who's going really in. It just knows the number of people batched and the number of people that are getting in,
Uh-huh.
independent on whether all those people have access. They just forgot to authenticate
Yeah, it's just a count thing.
versus
Okay.
someone who was going in without access, right?
Mm-hmm.
So that's how the Alcatraz started. We envisioned to have to solve physical access control initially for large enterprise and government, and then going down market to mid-size and even small
Mm-hmm.
companies. Everyone who cannot afford a guard on every door,
Mm-hmm.
everyone who values security and friction, and sees the potential of biometrics in a way that's very passive but very secure, to potentially replace eventually even badges
Mm-hmm.
as a way of access control. That's our vision, to be everywhere there are badges and more.
Mm-hmm. Awesome. Yeah, I see that there's a lot of problems with scaling the other approaches. As you're saying, there's like those turn things to make it so only one person can go through. You can have a physical guard. But if you're like inside the building, now it's cost prohibitive so that you cannot have like I mean, maybe if it's like a super, super important secret door, you have a guard there again. But like if you have lots of independent things that you might want people to access very specifically, if like say you're Apple or something and you only want people to know kind of exactly what they need to know, and not I don't really know because I haven't been there, but I imagine then a solution like this is really nice because you can scale it, um, the whole, I mean you just basically probably buy the equipment and subscription or however it works.
Exactly. And especially nowadays, in recent years, privacy and security is key for large corporations. And now it's going downstream into mid-sized corporations and small companies,
Mm-hmm.
due to them needing to comply with things like GDPR and ISO
What's that?
27001. GDPR, this is the European standard way to deal with privacy and security.
Ah,
I'm sure a
yeah,
lot
I'm
of
not aware.
the audience
I'm
here
sure.
have heard about
Yes.
GDPR. ISO 27001 is a similar certification that a company needs to have to prove that they know how to, and they have the process to deal with privacy and data.
Mm-hmm.
So if you think of a company, Apple is the extreme example, but any Fortune 10,000 company, even not even Fortune 50, Fortune 10,000 company, us as Alcatraz, not a Fortune 10,000 company, we have to comply with ISO 27001 rules.
Hmm.
We must show compliance with how we deal with access control, and on many of our doors, we have to have dual factor. Badging is not sufficient. We have to prove that we know who's inside those facilities. We know who's using our hardware and how they authenticate on the doors and on the computers. And this will become more and more of a challenge for many companies as they're moving towards uh, the new future of privacy and security.
Hmm.
as US is issuing federal laws, not only state laws. This will become a big issue, and they will have to prove a way on how to force those regulations into their infrastructure, their environment.
Hmm. See, I want to talk about
It's
those
like a dual
standards. Oh,
factor,
go ahead.
right? It's like a dual factor when you're logging into something online with Okta or with another service, right?
Yep.
How do you do it right now? Well, you get a text message or an email with a code to logging into your bank account, right? But what about in the physical world? You cannot wait to get an email to then go through a door. So
It
there,
would be
there must
painful.
be
Yeah.
something that could be painful. So how do you deal with this in a way to also have dual factor, very secure, but also very fast?
How is it dual factor if it's just looking at my face or doing? Where's the dual part of this? Is it just?
So depending on how the door is or the environment is set up, you can
Mhm.
do single factor, which is face or
Yep.
badge. You can do dual factor, which is face and badge. So essentially, you badge in.
Oh, yeah, yeah.
By the time you have badged in, a company like ours, there are more facial authentication companies or even any biometric. Specifically for us, we're very fast, so we would have already seen your face. We would know
Hmm.
what batch number to match it with. As soon as you badge in, we would compare the batch number to the face and the
Hmm.
connection to the face to the batch. And if both of those match, then we continue sending the batch number to the access control system to unlock the door. So that's dual
Hmm.
factor. You can
I
even
see.
do triple factor. We have
Yeah.
deployments in nuclear plants and government where badge and pin and face is a requirement,
Wow.
right? But it's all needs to be on the door. You cannot have something that you need to wait for as an email or
Yeah.
a text message. Uh, you can also do dual factor very passively. So, for example, your phone can be in your pocket, and just the presence of your phone,
Ah.
maybe with an installed app by Bluetooth range, can be the
Hmm.
single factor, right? So I can have my phone in the pocket. There is a badge reader with Bluetooth, which we also have the hardware for support. Um, Senses that I'm in front of the door using my phone. It senses my face,
Hmm.
and it just compares my face to the phone or phones around the door. And if both match, then we continue the batch number corresponding to the phone
Hmm.
assigned batch number
Yeah.
to the access control system to open the door.
Gotcha.
Yeah.
So you have all these different modes of sensing the person for authentication or author. How does it? Which is it? Authorization. It's authorization into a space, correct? Or access. It's just like.
Authorization, yeah. So we authorize people by authenticating them
Yeah.
with their
Okay.
face. Yeah.
Awesome. And so you have all these different ways of doing it: Bluetooth, the badge, um, or
Any
actual
biometric.
keypad,
Yeah.
any biometric, so like fingerprints and this kind of thing. But the kind of core competence of your company is the face recognition. Is it true
It is the
or?
face. It is the face. We specialize in creating a very secure and very fast facial authentication transaction
Hmm.
between your face and our hardware and algorithms that run on the hardware.
Yeah.
We believe the face is the only way to do fast and passive biometric authentication just because the face is big enough to do it passively from
Huh.
distance. Fingerprint, you have to touch something.
Yeah.
Hand, you have to touch something. You have to maybe wave against something. With a face, you can just go through the door. And
Hmm.
essentially, the idea is you just keep going. You don't even have to realize something is going on. By the time you're ready to touch the handle of the door, it's already unlocked. The magic is in the background. How
Hmm.
the technology authenticated you, maybe matched your badge with face or phone with face. But your experience as an employee is you just walk as if the door was anyway open,
Hmm.
right? Because you don't want to be in a situation where you have, many people, 10, 20, 30 people per minute going through, and everyone needs to stop and wait
Yeah.
and
Oh, it'd be
touch
awful.
something and authenticate. What about the person who doesn't have access?
And then they just hold
Or the
everyone
person
back.
who they hold everyone back, or they just piggyback and get into the other
Mm.
side and they steal something, right?
Mm.
if someone steals IP, depending on the company, it can be devastating for the company. Like imagine someone stealing the schematics and the layout of the new iPhone and posting them on Twitter or something, right? so you need to have technology that's very passive, but also very accurate. This was the biggest issue on why facial authentication has not picked up yet as a biometric. Fingerprint is kind of accurate. You can have a false acceptance rate on the fingerprint in the sense of maybe 1 in 50,000, 1 in 100,000, which means you can enroll 50,000 people and most likely may not have an incorrect match. Iris is also very secure. Hand geometry is kind of secure, but the issue with
what was that? Iris?
hand
The eye?
iris is very secure. Yeah.
That's probably pretty invasive. That makes me think of like movies where they're scanning.
It's invasive and it takes a long time, and it depends on lighting conditions and your sunglasses and how dark they are.
For sure.
So all those are issues with biometrics, with old school biometrics that were preventing biometrics to really pick up in physical access control. Fingerprint and hand geometry obviously depends on how clean your finger is. Maybe I'm sweating a lot. Maybe I'm a construction worker and my fingerprint has already washed out forever, or maybe it's dirty every day and there's no way. Exactly. So those were many of the issues. And face, just intrinsically, our faces kind of look alike. I don't know about yours and mine, but definitely they look alike more than our fingers. So if you use if you use facial recognition, not facial authentication, but facial recognition, and usually when you enroll 100, 200, 300 people, you start getting incorrect matches. The best facial recognition algorithms, the ones that go on NIST, the National Institute of Standards, where they benchmark facial recognition algorithms, from all the best companies in the world. They're reaching false acceptance rate of maybe 1 in 100, maybe 1 in 200. There is no way you can deploy those in a large corporation. You can deploy those in a lab, having 50, 100 people. You can deploy those at home or in a small company. But there's no way you can go to a Fortune 100 company and enroll 10,000 people. Not only because you will start getting incorrect matches, you will not even get there because their security teams at this point, they know how to test technology. They will test your technology before they even deploy it. Just a few of the facial recognition products they'll put on the door, and they'll immediately find out that you cannot deploy massively within their environment. So so that's our one of our core IPs. We do facial recognition or facial authentication based on 3 sensors. So essentially, instead of using just one camera to see the face, we use color, infrared, and 3D to see the face, and we kind of overlap those 3 cameras built into our product.
We say the 3 cameras again? It was infrared.
RGB or color, infrared, and 3D.
And 3D.
So 3D infrared and color. And the idea behind that is it's like a backup of a backup. We use all the 3 cameras to do facial recognition or facial authentication. We use the cameras to adjust for the different lighting conditions. Maybe it's evening time or during the daytime. Maybe there's a bright light coming from behind you. Maybe sun.
Does the
setting.
infrared kind of supplements and thinking about it now, maybe it's like the preference is the 3D, because then you can get some head information, so you can see the shape of their face. Then maybe there's the infrared.
Preference is actually on the color side. The most information that we see is on the color side. 3D really helps to see the face in 3D, which creates a way for us to check for spoofing. So I don't want to
if I have a piece of
on LinkedIn. Yeah, I don't want to look you on LinkedIn and show a picture of you on my phone and unlock the door, right? Which happens with most facial recognition-based technologies, because they have no way to check whether the picture is live, the picture is a real person. And especially nowadays with deep fakes. I'm sure the
Yeah.
audience know what a deep fake is, right? How to create a face that looks like a real like a real face, maybe of a celebrity speaking and
Yep.
mimicking, doing whatever you want, but actually it's not. You don't want to use now there are iOS apps that create deep fakes out of
It's
nothing
insane.
for
Yeah.
in seconds. Uh, there is no way you can deploy technology in large enterprise and government that will be able to be spoofed by deepfake. So you really need the 3D component. You really need to make sure the face that you're seeing is actually has the depth, and then a bunch of algorithms that we use to make sure it's a living face, not just a mask.
So what if I like I'm trying to break into a secret base, and I take like a ski mask that has someone's face printed on it. Would that pass the 3D filter, or like so if you have access to the secret base but I don't, if I took a picture of your face and then put it on a ski mask, like 3D printed it, and not 3D printed it but printed it onto this
Yeah.
and then like covered my face in it, would this fool the 3D thing because it's like, oh, it's a
You're
round?
Without going into the specifics about our algorithms, I advise you first to try to create a ski mask out of human skin.
Yeah.
Maybe you
Like Hannibal Lecter or something. Yeah.
yeah, no, that's a good idea. So
But I mean,
yeah,
just like,
there are
so
different
it,
algorithms to
oh.
to detect the material as well, or what
Mhm.
the face is made out of.
Oh. Does the infrared help with that? Like maybe the reflectance or
Yeah,
emissivity or some sort of,
yeah,
ah,
you're
so
correct.
you weigh a lot of things with your
There are a lot
sensors.
of algorithms, and that's what's setting Alcatraz apart from anyone else. Most of the facial authentication companies are doing the matching somewhere in the cloud or in the computer somewhere in the back,
Mhm.
and then do just a simple matching with maybe an off-the-shelf camera or a prepackaged camera that they put in a box. We do everything on the edge. On the edge means on the door. We make all the decisions on the
Local.
door without the
Yeah.
need for cloud or an on-prem server. Everything is on the door. What's coming out from our product is just a batch number.
Hmm.
But until we get it to a batch number output, there are a lot of algorithms to do facial indication and spoofing based on 3D, color adjustment, and auto a brightness, contrast adjustment to make sure we get the most points out of the face, independent of the lighting condition. Exactly like you mentioned, infrared sometimes will kick in more
Yeah.
than color, depending on the lighting condition, to eventually have the goal of, okay, now we see the most and the best points of the face. We've seen your face multiple times in the last X many milliseconds or a second. We've
Hmm.
captured that. We saw the face a little bit moving, or maybe from a different angle. We're seeing the velocity of the face in the body. The body is also very important for us. Uh,
Yeah.
you know, all the other companies are just doing face as one face. You usually have to even look at yourself on a display box and put your face inside a
Oh yeah, I've seen those. Hmm.
pre-graphed facial portrait, right?
Yep.
We also look at the body, right? Because the body is also key.
Oh
Imagine
wow.
imagine I'm trying to tailgate to get into this base that you're talking about, and I
Hmm.
know I'm tailgating. I know I will get recognized, and I'm obscuring my face. Maybe I'm texting, or maybe I'm really obscuring my face. Maybe I have a hat, sunglasses, and I have my hand over my face.
Uh-huh.
Then there is no way any facial recognition algorithm will see a face. You will see a
Hmm.
hand.
Yeah, it's occluded
But if you
for
see the
sure.
body, then you'll say, okay, the velocity of the body means it will go through the door. Our product is designed in a way to see all the way towards the door. We didn't see the face, but we saw someone getting in the door that we don't recognize.
Hmm.
And you can immediately trigger a tailgating alert and send that to the security guards, just
Hmm.
based on the body getting in, right? So body is also very important, and all those algorithms to make sure you see the face in the best possible way. You connect the face to the body as well, because you don't want to disconnect the face from the body. You don't want to count the body and the face as two separate objects. They always have to be
Hmm.
connected. when people are going through.
Yeah.
All of that needs to come together on the edge within tens of milliseconds
Hmm.
to eventually output a batch number as if someone batched in. And it all it all needs to match into a database of potentially tens of thousands of people enrolled. But the
Hmm.
experience of the transaction needs to be as good as fast as Face ID on the phone, which is
Hmm.
swiping up, right? You don't realize what's going on.
Yeah, that's kind of been the gold standard for you while you've been
Exactly.
designing this. So how does it the what I'm imagining now is you have these three sensors, the RGB, the infrared, and the 3D information. You have that. Each lets you infer some different properties. Like you get the 3D person, you have it running a pose detector, so you can connect the body or
Mhm.
figure out the body. Then maybe you look at properties like emissivity of the skin or all sorts of like interesting things, and you run it through. Are you running it through several different algorithms in parallel, and you kind of,
Yeah,
if
it's
all
all
of them
different
check
neural
out,
nets. Exactly.
different
We
neural
had to
nets?
run this through several different neural nets,
Mm-hmm.
and especially so the neural nets are connected to how we do accurate facial authentication or how we do
Mm-hmm.
accurate anti-spoofing. And I think the most complex one is how you do accurate tailgating detection. Because tailgating
Mm.
detection is, the devil is in the details. There
Okay.
are a million different environments, physical environments in the world with
Mm-hmm.
doors and corridors, hallways, open spaces in front of those doors, and people at different angles and velocities that will approach a door, or
Mm-hmm.
maybe approach but not get in because they're just passing by. So we
Yeah.
had to do some heavy, data collection and training
Mm-hmm.
the neural nets to make sure we can distinguish between a person going into a space
And just
and
walking
tailgating
around.
versus walking around or hanging around the door
Mm-hmm.
or going through, but they're not tailgating. They actually belong to the space. They just didn't authenticate.
Mm.
Um, I would say this was the hardest to do.
That's funny that was. Okay. So for And this is all with the constraint of I'm going to have a little rectangle on the wall, and the rectangle is going to tap into the network, and all the computation happens on that, and the rectangle has all those sensors. So it's only this little box that goes on the wall that does this security, and that's why tailgating is such a hard. Well, one of the reasons why tailgating is such a hard problem, rather than having like the infrared sensor that we spoke of earlier, or some like other.
Yeah,
You have to infer a lot about what's going on
it's
through
very
just your
hard.
camera perspectives.
Exactly. Tailgating is very hard to do. Not only because you have to have a very fast and accurate technology, you have to tap into multiple things. You have to tap into um, knowing who's actually going in, knowing the identities of the people going in, which
Hmm.
means now your sensors that are checking for people and counting people, they're not enough. You need to know who's actually going in, not only the first person opening the door, but everyone else behind. Otherwise,
Yeah,
there'll be so many alerts to the guards that within days the guards will just not trust. They'll be
not listen
overwhelmed
to it.
with alerts, and at that point, any technology is useless, right? You need to provide very accurate, very timely alerts or information or analytics. Maybe the analytic is, hey, Fortune 50 company, you have 10,000 doors or 1,000 doors, but on those doors, maybe 10 of those doors have a real issue with tailgating. People tailgate there all the
Mm.
time. This is where a breach might happen the most. Think about that. As a Alcatraz, we may not know what's on the other side of the door or what's going on in the actual building, but the
Hmm.
security admins would think about, okay, out of those 10 doors, five are next to a key area that we
Hmm.
should not allow people in. And the most issues with tailgating are right there. And then they can think about actually having a guard on the door or actually having like a
Uh,
double door, a circle lock or a turnstile kind of a solution. They'll be blocking people. Maybe they'll have more separation with different levels. Depending on the
yep.
company, you may have different security levels. And when you go to each security level, physically inside the building, you get checked more. Maybe outside a
Yep.
single factor, you go in deeper dual factor, you go deeper into, let's say, a data center where you can access a server farm, triple authentication. No matter what it is, the company will know.
Yep.
That's the point.
Gotcha. So basically, you can scale, or if your solution lets the company scale quite a bit, and there are some cases where people are coming through so frequently, and there's the tailgaters coming through, um, then in this case, they can take additional precautions by adding a guard or something else, and your system's a supplement by having it be everywhere because it allows that scaling. Although it may not perfectly solve the problem in these
There are
really
no
hard
perfect
cases.
technologies for sure,
Yep.
but they're almost perfect technologies that will give amazing value
Yep.
based on technology.
Yeah.
We pride ourselves of having rocks. Rocks are the hardware edge units, the triangles that you mentioned that you deploy on
Yep.
the doors.
Oh, they're
We
triangles,
can
not rectangles. Okay.
rectangles, triangles, whatever it is.
The shape.
We can
Yeah.
deploy 50, 100 of those for the price of one
Hmm.
guard, right? And they're
Yeah, it's
guarding
nuts.
24/7.
Probably
They're
per
not guarding
year.
just one shift, right?
Yeah.
Exactly, per year. So if I'm a company and I have a budget for one guard, even, why would I? Or let's say two. I have budget for two guards. I don't,
Hmm.
and I have maybe multiple buildings, tens or hundreds of doors. There is no reason why I would not use half the budget to deploy rocks massively everywhere and have just one
Yep.
guard looking at the data. Right? So that's how I
Yeah,
think
for
about
sure. Uh-huh. So with tailgating, so from the user experience, you want it to be as frictionless as possible. And so for this, it means that you don't have like, say, like an airport security style. One person goes and the next person goes. What you're striving for is like people can just walk in through the door very naturally,
it.
one after another. And this is one of the reasons tailgating is so difficult.
Or at the same time, actually. Maybe a couple
Or
of
at the
people
same
can walk at the
time.
same time. Yeah. Depending
Huh.
on the door. In many locations, you have a dual door environment, right?
Hmm.
The two doors open up. So multiple people can go through at the same time. So you need to authenticate both.
And so you try to basically everyone that goes through, you try to authenticate, and then once you have this, if you don't, then you say, "Hey, guard, check out this one suspicious person."
Hmm.
Uh,
Exactly.
Gotcha. And okay, very interesting. It sounds like a hard problem to me. Very hard.
It's a very hard problem. If you think about facial authentication and tailgating, it's kind of like solving a problem, the problem with self-driving cars, right? So self-driving cars essentially is a problem based on creating very accurate, fast, and eventually cost-efficient sensors, getting
Hmm.
the data from all the roads, and then training based on the data, and then deploying it into something that can ingest now the real-time sensor data from the car in a way that will drive your self-driving experience from a level 1, which is nothing,
Hmm.
level 3, which is
To
something, all
four,
the way to level 5, which is maybe I don't have to be in the
it
car.
can be James
But to
Bond
get to level
driving. Yeah.
5, you see what's going on with Tesla. Tesla has millions of cars nowadays. Every car is collecting data for Tesla, and even Tesla
Hmm.
can't solve it yet. Maybe on the highways a little bit, but it will take a few years, and then a few
Hmm.
more years, from a legislation perspective. But especially if you go into not well mapped roads, maybe even outside
Hmm.
US, then it's becoming an issue, right? So
Hmm.
same idea with technologies like anti-tailgating, which is our one of our core technologies. You need a lot of data, you need to
Hmm.
train and improve. The devil is in the details, all the corner cases.
Yeah.
We can prove that we are more accurate from a facial indication perspective than a guard,
Hmm.
and from a tailgating perspective than a guard or a turnstile. And Tesla
Hmm.
can prove that even with their self-driving technology on highways and overall, there are less accidents when
Hmm.
self-driving is turned on versus not, right? But to get to a level 5 experience, and in our case, to get to a level 5 tailgating experience, which is you catch 100% of everyone, uh, and you have zero incorrect alerts,
Hmm.
we need time. to get even
More
more
data,
data from
everything.
more environments, more people, everything
Yeah.
just to just come in more detail.
hmm Now, with the heavy reliance on neural networks for a lot of this, how does it, like, I mean, I've seen funny things where they'll, I don't know, like they'll put a pixel somewhere in a stop sign image or put a sticker on a stop sign, and now the self-driving car, I don't, not Tesla, but like research ones, where
Mhm.
it will identify it as like a green light or something terrifying that it is not. Or just an image recognition thing. You change one pixel in some sort of adversarial network, and then it thinks it's something else. How is it working with such safety critical systems, or like security is really important? How do you make sure the neural network's not doing something unexpected?
Well, we have to keep innovating. That's the point, and
Yeah.
that's the value added. When you go into especially large enterprise and government deployments where security is key, you got to
hmm
keep innovating and putting down security patches, accuracy patches, anything that comes out that we see can potentially be used as a spoofing attack, as a liveness
hmm
check attack or a spoofing attack. We need to work on it, then solve it, and then update our rocks on campus immediately
hmm
as soon as we can to you know, for this not to happen potentially.
Yeah. Is there, so, and then how would you discover these? So, okay, there's a new one. Do you read about it in an academic paper? Does some really knowledgeable person be like, hey, this is a thing? Do you have bug bounties? Like, how does it work to
All of the above.
find these?
We
Oh,
can
yeah.
find it in journals, scientific papers, university papers. We can find it on YouTube sometimes. We can find it just based on feedback by security admins. We're doing a lot of
They're
pilots
like,
with
this guy went
companies.
in with a sticker on his head and it confused a thing
Yeah,
or
yeah.
something.
Different kinds of we've had so many ideas coming from the security admins regarding our tech on how to create complicated masks or even non-complicated mask like socks that you mentioned. If you print a face on a sock and try to get it, but the
That'd
sock
be
needs to
hilarious.
be
A sock puppet walking in.
exactly right,
Yeah.
right. So we get data from every source, all
Uh-huh.
sources that we can, and we have a team that does the research, and if needed, we start work on it to make sure it doesn't happen for us.
Yeah, it's just it's an interesting thing because it seems like a lot of times. So if you take a more classical AI or classical machine, I don't know, like say you're using in computer vision, like you're using old computer vision algorithms like SIFT and things like this that are very like established and classical, and we kind of know what they do. You can like prove how they'll behave in most situations and get more expected results. But with neural networks, it's like it's somewhat interesting where they can it'll create some model, some representation that it'll then pass the data through, and then it might come up with unexpected results if they're not in the training set
Yeah,
and this kind of thing. So then
correct.
it's like
That's why.
you're watching it rather than engineering the safety in. It's an
Yeah.
interesting change to me. Or
Uh,
what do you think of this? Like, this is my
uh,
perception of it.
so for sure. There are many or multiple ways you can solve this, or you have to be careful on how to do this. One is um, never test with the data that you trained with,
Oh,
right?
of
So
course. Yeah.
two different sets of data, and
But
build.
it's still, I mean, interpolation when you have new data is still a thing. I mean, you can,
Yeah,
of course, you do the train test split so you'll overfit like crazy if you're not doing that proper split. And then you'd get just really, really specific results, which wouldn't generalize well. But then,
yeah,
I mean, I'm saying like if it's a new, say like a person in a wheelchair comes, or you have someone who's like their body is different for some reason. Maybe there was like an accident or something. Like it would be undefined behavior in a sense, and then the network might do something kind of funny.
yeah, for sure. So there are all kinds of corner cases.
hmm
We've been deploying our products for many years, getting those corner
Yeah.
cases and trying to train for them.
hmm
And we've developed very automated tools on how to check whether we solved for them. So you
Yeah.
should never check whether you solved based on field data, right? We cannot update the firmware of the rocks that are already in the field, a large groupation, and see how they'll behave. We have to make sure it's already solved before we
They
update.
would like that for these like big
So how do you
governments
do
or
that
whatever. Yeah.
with
Uh-huh.
tens of thousands, hundreds of thousands, millions of faces and bodies and corner cases, people approaching doors to check for tailgating? You just have to automate everything. And
What do you mean? I don't understand what you're automating.
you have to automate the testing of your updated machine learning algorithms. Let's say,
Just on historical data, you're saying though, correct? So it's like
yeah. So
basically you have if they went through and you know if they're a bad guy or not, and then you just you test based on that data, right?
yeah, like
That's how you basically.
your example, for the wheelchair example, right? You
Hmm.
see someone on a wheelchair. Maybe you didn't think about how the algorithm will react when
Hmm.
they're tailgating, or maybe they're too
Yeah.
big of an object, maybe they're too slow of an object, maybe the face is too low for the algorithm to
Hmm.
detect their face. So then once you see that you have an issue, you may have an issue with this,
Hmm.
and Alcatraz is fully ADA compliant. That's a good thing for us. But it took
Fully
some
what?
time.
ADA compliant,
ADA
you
compliant,
said?
right? But it
Good.
took some time,
So
right?
accessibility compliant. Yeah. Because I
To
imagine it's
develop.
like I'm on crutches and that's like a new form of person.
Yeah.
And then, I mean, even like I'm imagining like, say I'm an amputee. I don't know if your person tracking would work as well or these kinds of things.
Yeah. So very good corner cases. You have to have data. Uh, but
Hmm.
think about that amputee person that you mentioned. Now you have to create data based on them approaching a door, based on like 1,000 different angles and
Yep.
velocities to
Yep.
accommodate them eventually, potentially tailgating in an actual environment, right? So how
Yeah.
do you do that? Well, you can hire an actor to do it because
Hmm.
that data does not exist.
Yes.
I'm pretty sure. Or something interesting is happening in the last couple of years. You can create data. You can create synthetic data.
Do you do it in simulation? Oh,
You can
okay.
simulate. You can create data based on parameters. Maybe that person is also approaching the door, but the sun is shining at 45 degrees, and they have beard and some kind of sunglasses and a hat, so we can see a face, and they're maybe texting with
Yeah.
one hand
And a
while
backpack on their lap. Yeah.
with a backpack, maybe carrying a baby in front, right? Right.
Yeah.
So you keep adding objects to your simulated data, but then you can create 1,000 of those, right? You have
Yeah.
your 1,000 different scenarios, and you're just creating the people, the graphically to run through those use cases.
Yeah.
This is also something that should be used more when you
Do you use this now? This is quite, so
we
it's basically so you're saying simulation of environments. So you can basically train a policy and get it most of the way based on a bunch of, or generate a bunch of synthetic data from a realistic simulation where you can control the lighting and you can control the person and you can make them be carrying stuff and have 10 babies strapped to them and
yeah
all sorts of things. So
yeah
you guys
so
use simulation to?
we are heavily looking into it to add on top of
Oh,
our algorithms. We haven't yet,
yeah,
just because there was no way to create as detailed of
for
that kind of
sure.
data as we would like. Imagine the data, let's say a person going to a door
Hmm.
needs to have a face attached with great detail, so we can run facial recognition on the face as well.
Hmm.
Simulated data started originally to create environments for cars for the purposes of self-driving. Cars are big; you
Hmm.
can create just objects, kind of blocky objects. Now
Hmm.
companies, and there are only a few companies in the world, are creating more detailed data that will suit such things as facial authentication, connected to a body that's moving with, some kind of an animation that resembles a human being towards an
Yep,
object. Yeah.
that'd be interesting. There is, so, and then how do you handle that kind of simulation gap? If you, so I guess you're looking into it, so you haven't figured it out entirely. But I'm aware of, like, I did reinforcement learning on a legged robot to try to do parameter tuning. And so we had a simulation of the robot, and then we also had the physical robot, and we could like learn really well how to make it do all sorts of things in simulation. And we try to take those parameters and bring them over to the physical robot. And if anything, they were only an okay starting point for
Yeah.
parameter tuning. So like there is definitely a gap there.
So the gap right now we fill with actors,
Cool. That's
right? So
awesome.
we essentially, as soon as we find a some kind of an example in the field that we need to train for,
Hmm.
then we hire an actor, and we give that actor 1,000 ways how they can act on that.
That's
And
awesome.
within a few days, we have the data to now train for.
And you have like a super camera capture setup, I imagine. So you like, I would imagine like you have like 10 devices on the left and 10 on the right and a few in this angle. So you can generate a massive amount of data when the actor does just like one thing. Is it correct?
We have a few, not many. We have a few because they, our product needs to be mounted at a specific height,
Locations. Oh, okay.
right? A specific
Oh,
location.
that's one way
So
of making it more, so your data becomes less general in a sense because you fix the height.
yeah, and we chose our height, which is around 5
Hmm.
feet, so we can basically authenticate people for ADA purposes all the way up
Ah,
to NBA players, right? Something like
that's awesome.
7.4, 7.5 feet height.
Hmm. So is the kind of role, so you have this system, the system gets really good data. You have actors that are kind of in the crutch situations where you don't have a bunch of training data for like these one-off things. Does it feel like the company, once you have your product out there, it's like catching up with corner cases because there's so many things that just occur that like are outside of your training set, basically. So it's a lot of like, I don't know, hiring an actor to
Recently, not
walk
as
this
many.
way, or
Yeah,
because
yeah. So
you're
it took
actually
us years.
catching them all, maybe.
Yeah, so
Yeah.
it took us years to get most of the corner cases. Now, very rarely
Hmm.
we see a corner case that we haven't thought about that we have to train for.
Hmm.
So that's one aspect of our continuous training. But the other aspect is how to make things faster,
Ah.
faster and um, I guess faster is the main thing, and supporting all kinds of environments, right? So how do you
Hmm.
make things faster? You also need to train based on different corner cases, but also based on landing conditions or velocities of people
Hmm.
to basically be able to authenticate on every frame as soon as you see it, not wait
Oh.
and wait maybe to authenticate on frame 5 or 6 or 7 because that's the frame that you see as the best frame, right?
Hmm.
How do you see the first frame as the best, and that's enough to authenticate, but still gives you
Gotcha.
enough accuracy and security.
Gotcha. So if they're 10 feet away from the door that they're about to go through, you have already authenticated them. That's the ideal. And then, so if there's a bunch of people, then you can authenticate them all super early and super quickly,
Mhm.
so that just in case more people come out of nowhere, you have them, you have the
Uh,
available processing and
so it's great to authenticate early, but
yep,
also you got to be careful because at 10 feet away, you may not be
they could go
sure,
anywhere else.
yeah, whether they're actually going to get to the door. So you may know who the person is 10 feet away,
Hmm.
but actually have to double, triple check their intent
Oh,
or velocity. They're moving towards
I
the door,
see.
maybe frame 10, they're closer, frame 20, they're even closer, and then pull the trigger, which is basically setting the batch number to the access control system to unlock.
Oh.
Otherwise, you're going to just be unlocking the door nonstop of people just passing by.
Yeah, gotcha. That'd be kind of funny. Yeah, because you have to intent. You have to understand their intent, which is hard. And that's why you need the velocities and things. And that's probably, and the 3D camera helps a lot with that. That's quite cool.
Exactly,
Okay.
and that's where AI comes along as well. Because now, if you have uh, hundreds of thousands, millions of authentications
Hmm.
based on different environments, then and you train based on that. Now you know a little better, what intent is, whether the people are just hanging out by the door, they're actually moving towards the door. And then you keep training and training, and then you decide, okay, maybe I don't need 4 or 5 frames throughout the next second. Maybe I need only a couple, which means you can optimize your product to go faster, to go for more faces, to go for larger field of view. Maybe range will be a little longer. All kinds of those parameters will help to create a better experience. The experience is key. Like getting the most faces and people who intentionally going through a door and recognizing who doesn't belong. That's the bottom line.
Yeah. And so for these systems, what's the business model of Alcatraz? Is it that they buy the equipment for you and the equipment kind of runs on their own network, or is it like a subscription thing, or how do you guys interface with customers?
Yeah. We are a hardware as a service company, and depending on the customer, we have 2 ways to deploy a product. One way is cloud-based, which means all the rocks deployed.
And rocks are the security stations at each door, right?
Yeah, rocks
That's
is the camera that goes above the battery heater, the multiple cameras built into the product with a chip that runs the whole thing real time. Gotcha. So the rocks need a way to communicate to each other, right? That way can be through a cloud, kind of like iCloud, right? If you have different iPhones or iPhone and iPad, you want them to have a common cloud where all the data is backed up, your pictures, your files, and so on. But many organizations still would like their cloud to live on premises, completely air-gapped, which means the cloud, the backup machine that runs our UI UX of analytics and backs up all the profiles and batch numbers, it can never touch the internet. It's only on their security network, completely offline, always, with some way to update the software of the on-prem solution and also the software of the rocks. That update mechanism can be as simple as a file on a USB drive, old school way.
That sounds painful if you have like 50 or 1,000 or whatever.
It is the legacy way of doing things, but we have to support it.
It does work.
We have now many ways to update our products, many ways to deploy, but essentially we're hardware as a service with 2 options to deploy cloud and on-prem. And what's worth mentioning here is, as I mentioned, one of the main issues with biometrics so far, a couple. One is scalability, cost and scalability, which is they only solve for one problem, which is authentication, not making sure really security is really heightened by checking for everyone passively. Especially for facial recognition, scalability is an issue because just using facial recognition on one camera is not accurate enough. The second main issue with deploying biometrics is the essence of deployment. You need a lot of man hours, a lot of infrastructure, a lot of time, which costs money to deploy something as simple as a fingerprint reader. You need an integration with the access control system. You need a special, like an old school way to enroll the people, which is like, imagine if you're a company, let's say a Fortune 10 company, and you have 20,000 employees. Yeah. And you want to deploy a biometric somewhere on the main location, somewhere maybe on the turnstile in the lobby, but everyone needs to have access to it because it's a main location, general location. Then you need to call 20,000 people to the badging office to enroll.
Oh, yeah.
That's a no-go. No matter if the technology is made by a small startup or a large corporation, security admins just don't want to go through the pains of such significant enrollment, no matter if it's COVID times or not. So how do you solve for this? As at Alcatraz, we have one of our core IP technologies, and we have a patent on it. Is we use AI, real AI, to enroll people passively. So instead of you going to the badging office and spending half an hour, being in line, they take a picture of you, they connect it to your identity. Maybe you have to show your ID. They do the integration with the access control system. We we don't ask employees to do anything but just use their badges on the badge readers they're anyway using. So imagine you're going
That's
through
clever. So you get the
the
data while
main,
they're going through the first time.
exactly. So you go at 10 a.m. on door 1, 11 a.m. on door 2. You're just badging in the same way you badged in yesterday and the day before with your normal badge. Within a few times, we'll see, okay,
You
it's the
have a
same
good
badge
model of
number,
them.
same face, maybe a little bit different angle on the face. That must be the owner of the badge. Well, now we bind that data. We purge all pictures, so we don't store any visual data. To another core IP is we per selection of the admin, we may be PII free. We don't have to store any pictures, any
So that's
personal data
personal
of any employee.
information,
Yeah.
right? Personal
And at that
identifiable
point,
information.
yes, and at that point, we distribute your profile with a batch number to all other rocks on campus, including either cloud or the on-prem instance backup. And then at noon, you can just walk to a door that has a rock already, and by the time you
Go
touch
right
the handle
through.
of the door, by the time you even have, even maybe you don't know that you have been enrolled, by the time you have a chance to take your badge out to badge in, the door will be open already with your face.
That's so
Right?
cool.
So that's the idea.
Yeah, it is like magic. I mean, and that's always such a clever way to enroll people. Just get them scanning and then you label it. And
You
then,
just keep badging.
so for sure. Then, when what you're saying, then you don't store any of the photos and things that you took of them. I'm imagining what you do is you take a bunch of information, it goes through your algorithm or your neural networks, and you effectively get like a hash for a person, and then you match that up against some sort. So it's basically the function is the data that the system gets when the person walks through. That returns some sort of like hash. It's like a password, basically, based on the data that you're getting, and then you check that against what you have stored for that person.
Other
Is it
hashes,
like this?
but yeah, but no pictures are
No
stored.
pictures. Yeah,
As
just
soon
the
as we
hash.
convert the picture to a hash, we remove the picture. Of
Ah,
course, the admins, if they have the policy to store the pictures, to see the
they
pictures in
can.
their admin
Yep.
panel, they can. But if they are deploying in a very secure environment, let's say somewhere in the government where you should never take any pictures of anyone, then our product will not transmit or store any pictures anywhere, right?
Gotcha.
Which is different than anything else, especially products that use the facial recognition algorithms that are being done on the on-prem or cloud instance. It's a big issue, right? Because now you're transmitting a bunch of pictures to the
Oh
cloud and
yeah, for
on-prem.
sure. Yeah, that's why
It
local
not
is
only
such a nice
creates
thing, or edge, as you say.
it not only creates a lot of delay, but it's not secure at all.
Yeah, that's really cool. And then so what are kind of the limits of your system in terms of how large the organization can be?
There are no real limits. You can deploy any organization, any enrollment number.
And
Of course, if you
how
go
does
to a company like Foxconn, the largest factory
yeah,
in the world,
that makes
they
Apple
have over 1 million
products?
people, right? But those
Yeah,
million people don't
that's
need to have
insane. I
access
didn't know
on
that.
every single door. Oh yeah, they don't. Or Walmart. Walmart have over 1 million contractors, but Walmart doesn't need to have
Insane.
all the contractors to have
Have
access on every
access to
single door,
something.
right? The contractors can have access in a specific building or warehouse or a retail store. So we don't need to store 1 million profiles on the edge. We only need to store
However
whatever,
many access it.
1,000, 5,000, 10,000 on the edge. Everything else can be backed up in a common cloud, either
Mhm.
on-prem, given by the customer, or we provide the on-prem solution, or we provide the cloud solution. And over there, you can back up millions of profiles. It doesn't matter.
That's nuts. So what features? I mean, I know you have these three cameras on your device, but what can you give? I'm sure you can't say exactly, but can you give some intuition of what kinds of features the algorithm or the neural networks are picking up that allow you to have such a huge number of people represented with this recognition software?
I mean, it's
Like,
just the
is it looking
way
at my
that we use
pore
three
size or
sensors.
like, oh, go ahead.
It's just the way that we use three sensors is just giving us more data. And the way we ingest the data, we have more clear way of viewing the points
Hmm.
to have more accuracy on them, to be more sure that okay, those points are really really what we need. There is no blurriness. You know, blurriness is and lighting conditions are the two worst things for facial recognition.
Hmm.
But when you create a product that removes blurriness and works with any lighting condition through algorithms to undo different lighting conditions,
Hmm.
then you have a higher chance to authenticate, with more accuracy. Um,
Hmm.
so that's all I can say. I'm also very proud. Very early in the company's life, we patented this thing, and our patent lawyer couldn't even believe that the USPTO granted us the actual patent. We have a patent on any facial authentication product for access control using more than one sensors.
That's insane.
And
You
I
just like
believe, yeah,
one plus all
I
is out of
believe it
limit.
can, exactly,
That's
and I
ridiculous.
believe accurate facial authentication cannot be done with one sensor.
Yeah, you're
Period.
probably right. I mean,
Not even 8K HDR plus
that's it.
or whatever it is. You cannot.
I mean, I'm happy for you guys to get such a like comprehensive patent, but that seems like a failure of policy to give you that broad of a patent to me. But
I mean,
because I mean, it's just
it's
any other innovations of whatever. Because more sensors, more information would be better, and just that's crazy.
like
I mean, what
imagine
a
Tesla
powerful
getting a
patent.
patent on doing self-driving with more than one camera.
I know. Yeah, it's the
Something,
same thing. It's nuts. How crazy.
yeah.
Okay, well that blows me away. What so how are you thinking of patents with this? Because with I guess so that's like a hardware one in a sense where you say that this setup. Are you patenting your algorithms or your approaches or anything like this
Uh, Selectively,
selectively?
we were patenting some like tailgating, uh, anti-tailgating features.
Hmm.
But some algorithms we choose not to patent because then in
You have
18
to
months
expose it
things will become
or
public information,
oh,
and we better not expose how we do anti-tailgating and also spoofing, right? How you check
yeah.
for the face whether it's real using 3D. You don't really want to give away the way you did the algorithms because
Because people
then
can pick at
it's
it
a,
and try to
exactly
find
people can reverse engineer
vulnerabilities.
and exactly.
But so at the same time, what would happen if you made this open source? Because then you could have a lot more public scrutiny, and it might make it stronger in the limit, like with all of the
Um,
scrutiny. I'm sure it's
it's
not
it's
as compelling
challenging.
from a. Oh, go
Yeah,
ahead.
it's challenging to make things open source because they're so closely connected to the hardware. It's like
Ah,
imagine like Apple making open source their algorithms for Face ID, but it only works with their specific 3D
hardware
module and RGB
configuration.
and infrared
Yeah.
camera that they created, as a Face ID array.
Hmm.
So it's difficult, and um,
But I'm
us
sure like
making
the
things open
training
source.
pipeline or things like this could be generally useful because it probably isn't. Is it incredibly specific to the camera that you're doing? Like I'm sure after you kind of normalize the images or something that they're fairly similar. You probably just change the vector size or something like this.
I mean, the 3D module, the 3D sensor has a specific resolution and
Hmm.
frequency that we have to go, we just have to abide by.
Gotcha.
The RGB camera has a specific lens with
Hmm.
distortion that is preset, and we have to compensate for it. So
Gotcha.
it's not impossible, but it's not going to be. If
So
anyone is
valuable.
using a different set of hardware, it's not going to be the same. And especially if I think about, for example, 3D. So 3D, you can have multiple ways of sensing for 3D, right? It can
Hmm.
be stereo, which is two cameras,
Hmm.
right? And the difference between those. It can be time of flight, or it can
Hmm.
be structured light. So what is
Hmm.
time of flight? For example, time of flight is there is an infrared projector somewhere, and it just blasts some infrared out that will bounce somewhere else in front, and the sensors are just picking up, basically calculating the time that the
The
infrared
light is in flight
uh, uh,
to go there and back. Yeah.
bounces as a delay, right?
Hmm.
So So, having a specific 3D or 3D module at time of flight, which means the sensor needs to be exact with the resolution, then the projector needs to have a specific frequency, but also at whatever power it's driven, then it will be able to go further out, especially under the sun at
Mm-hmm.
bright lighting conditions. Infrared has this property that it kind of dissolves because there's a lot of infrared out as well. So the
Oh,
more
okay.
powerful the projector is, the longer the range would be, especially outdoors, right?
Mm-hmm.
So that specific combo with the power that's being driven at is proprietary, and it's built into the algorithms themselves to make
Yes.
sure we have exactly the range we want, or maybe we can
Mm-hmm.
adjust the range based on the data we get real time, based on where the rock is deployed in different lighting conditions, right? Because
Yeah,
essentially you don't want to have different SKUs for outdoor and indoor. You don't want to have
it
different
makes sense.
SKUs of products based on where you deploy. You want to have a product that kind of self-calibrates
Yep.
no matter where it's deployed and adjusts and performs always at its max, but it also at its best.
Yep. And so what about, so I understand that you're saying everything is very hardware specific for this and that it's, you build the whole system around the hardware and, because it's highly optimized, because you probably want to have the smallest, cheapest thing you can for each of the doors because companies are going to buy a lot of them. But one other thing that I'm wondering is how do you handle updates of hardware components? So if you want to, oh, this other camera, this infrared camera comes out and it's better than the one you're using, and it's due for an update, then
Yeah,
does that break all of the training data that you have? And then it just,
very good question. I love it. Yeah. So we strive to be backwards compatible.
Mhm.
So anything that's already deployed and anything that will be deployed in the future from a different hardware perspective should use the same enrollment data, right? You don't want
Mhm.
to have 100,000 enrollments at a Fortune 20 company based on the first generation of a product, and then
Mhm.
we create a new generation based on, you know, smaller, cheaper, uh, faster, better, but
Yeah.
then ask the company to enroll again 100,000 people.
Yeah,
So this is also very important and also very hard to do, especially
I bet
if we don't store the original images of the
that you
employees
trained the
to
things on.
train
Yeah.
on them again.
It'd probably be hard too because you'd have to interpolate or something. Like you would basically, with this sensor, I read it in like this, but with this sensor, I would expect better resolution or some different distortion or whatever it might be. But so you try to make it compatible, which maybe means running the old algorithm on it in a sense. Like you try to get your current sensor to represent information like the previous sensor, and then you just run it through the same thing, or
Without going into specific details, because that's also part of our IP,
yeah.
the end goal is to have multiple different products deployed on the same network in the field, different
Hmm.
generation of products with different camera parameters that potentially will generate different hashes, different enrollment
Yep.
profiles based on the sensor data, but still, uh, but start from the first or the first generation of a product that was already deployed and use
Hmm.
that enrollment data and then transfer it somehow uh,
Over to the
with
newer
a
one.
transfer table or whatever you want to call it into a way
Ah.
to recreate new enrollment
Does that create
profiles.
false positives for that? Or I'm imagining, so if you have a hash and you try to map it over, you need to make sure that there's all unique mappings for this kind of thing, which sounds hard, given the
It is hard.
complex nature. Yeah.
It is hard, but it's solvable,
Ah, okay.
and we've solved it.
Oh, hell yeah. That sounds very hard. That would be awesome to have open source, but like that approach. But I imagine that that's a thing that you want to keep close to your chest because that seems like a hard
Yeah,
problem.
a lot of things going on. When I started Alcatraz, I didn't anticipate the complexity of the product. I used to be a consumer kind of a guy, and especially
Okay.
at Apple, you have thousands of people working on the project, unlimited resources from engineering perspective, financial perspective,
Hmm.
and then starting Alcatraz and then going deeper into the different aspects of our technology. Not only tailgating and facial authentication or spoofing or how we deploy, but eventually going deeper into privacy and security and to complying with all the regulations of large corporations to make sure we check all of their information security boxes. Sometimes it's 1,000 questions, 1,000 check marks.
Yeah.
It kind of feels like running multiple startups under one umbrella.
Interesting.
It's a team that needs to be doing tailgating. It's a team that needs to be doing facial authentication. It's a team that does the on-prem and the cloud instances for the customers, right? So that's kind of like puzzles that need to be kind of self-serving, but then also think about how to create software to then with minimal effort port into any new hardware, right? And still running. You don't want to reinvent the wheel every time when you have something new coming up.
Yeah, very cool. Yeah, that seems very hard. I don't know, through the conversation, I'm starting to see all these really thorny problems that you guys have solved to get to where you are. And I imagine there's still quite a few ahead.
It's an interesting problem set, for sure.
For sure. How do you, so how do you work with standards organizations, or how do you comply to standards? I don't really know how this works or what these standards look like, but like for access to a company, what kinds of standards do they have, and then how has it been using neural networks with those, like saying that those pass the standards? And
very rarely neural networks come into play, only in a few instances with very large banking institutions. They wanted to go deeper into how we create our neural nets, and they just wanted to make sure they're not going to interfere with their other neural nets that they're running anyway on their financial system. Which is impossible, and we were able to explain that both
you're like, they're different systems.
Yes, they're siloed, and our neural nets don't come out from the product. They just pick out the batch number.
I mean, yeah, I could see it being a concern, but it's interesting to be like, that's running on a totally separate thing, so they're fine. But yes,
nowadays, large corporations and soon, down the chain, a lot of the corporations are creating very specific, very detailed regulations on how they run anything IoT and any software on their networks. A lot of breaches are happening. That's why the cybersecurity business is crazy. A lot of startups are being funded. A lot of problems to be solved, accurately especially. And this is now transitioning into physical security.
Would you say accurate, especially? What did you say just now? I missed it.
I mean, yeah. So
like accurate, really accurate.
There are a lot of holes. There are a lot of holes that need to be filled in the cybersecurity realm of an organization. And now this is transitioning into physical security, because everything is becoming connected to the internet. Everything IoT, energy, utility, power, water, AC, access control, video management. Everything is connected now in a way to either the internet or some kind of an offline on-prem server. But then is that server communicating internally to something else or the network? So organizations, and on top of that, you have to think about the privacy and the security of the organization and its employees, using with PII and other data.
Personal identifiable
organizations
information.
Are learning. Yes, so organizations are learning and creating pretty detailed processes on how they vet any new technology, no matter if it's hardware or software, before they deploy even a pilot. Sometimes even as a pilot, even if it's a siloed pilot, they're very careful. So, for example, like you mentioned, if our algorithms, how we comply with standards, and whether our algorithms were being vetted somehow, on the deeper level by our organizations, we many times we have to deploy our products using a hotspot, like an actual hotspot, with
like a phone
Wi-Fi
that's
connected
supplying
to
internet.
Yeah, with a hotspot, like a specialized router.
Not a phone,
also
but
AT&T
just
or Verizon.
yep.
while we're doing a detailed information security review with the organization before they're able to even plug us into their internal security
Wow.
network.
Oh, that's nuts.
That only talks to other security IoT devices. Because you never know, right? You never know whether our product is outputting a batch number or it's outputting some kind of a code that can now talk to on a specific port to a video surveillance camera or something else and make it do things that it's not supposed to do. Maybe update the firmware there and do things that are not supposed to be done. So now organizations are getting huge regulation, some on federal level or state level, others just because they have to up their game based on previous breaches, and almost no one announces such breaches, obviously.
Oh, that's horrifying.
And we have to comply. And on top, we have to comply with anyway the rules of physical security. For example, UL 294. UL 294 is a specific access control standard. Any product that goes on a door that controls access control needs to go through this certification. In Europe, you have to comply with GDPR, especially if you're a camera, collecting or seeing people. In the US, as I mentioned, ISO 27001 or SOC 2 are the standards that we have to comply with and refresh annually to make sure we're still in compliance before we deploy many of the organizations we're deploying to.
Gotcha.
Yeah.
So for you to, when you say you comply by a standard, does it mean basically you go and you get a bunch of certifications, which mean that you go to a bunch of these independent boards and you say, okay, test my thing for this. And they go, okay, 100 people walked in. One was a known intruder, like a deliberate intruder who you should have caught and your thing didn't catch it or did catch it. And then if it works, then they say you are certified. And maybe there's like 5 of these or something, some number. So that you can say you are this compliant, ISO whatever compliant.
Sometimes you have to work with a few third-party agencies, yes, to test for things. They may test for accuracy, as you mentioned. They may test for cybersecurity holes that you may have on the product, on the edge, on the IoT product, or in the cloud, or on-prem. They're going to try to hack it. They're going to try to jailbreak your product.
Yeah.
Like you have to send your product, and they're going to try to solve things on it to see whether they can get into your. In our case, we use a Unix-based platform to get into the gain root access to extract something out of it. Right. That's called a penetration testing, and you must do it before you deploy into a large organization nowadays. On the access control side, you have to prove that when your product is connected to an access control system, it will function as is, no matter what. Let's say in a case of fire, you don't want your product to
open all the doors or something.
Open or close all doors and keep them closed.
Yeah, that would be horrifying. Yeah. Okay.
Yeah.
Neither's good.
So a lot of certifications. Yeah.
Interesting. How do you learn about these? Like, so when you started your company, how did you learn about all of these standards and then how to navigate all of these standards and the companies that go and test for specific things?
We announced the product. So the company started 2016. 3 years later, we finally be able to pilot. We announced the product at ISC West, which is the largest security show in the US, in Vegas every year. We announced the product at ISC West 2019, and we won Best New Product back then.
Congrats.
And during the conference, a lot of corporations just came by the booth and they wanted to pilot.
Oh.
Many Fortune 20 companies. So through the pilots, it's nice for them to say, yes, we want a pilot, but until you actually deploy a pilot, you have to go through a long list of information security IoT requirements, and we started completing them. And at some point, there is a common denominator. Okay, most corporations want for those
require these ones.
100 things.
Oh my gosh!
At this point, I think we've deployed to so many, and to the most strict ones we can deploy anywhere in the world.
Gotcha. How many of your rocks are out there in the world? Would you guess?
Thousands.
Like 1,000, like 10,000, ballpark?
I would say thousands.
Gotcha. That's awesome. That's probably a great feeling. There's a lot of doors being secured.
Yeah, it's an amazing feeling to have a product out, especially such a complex product that actually works.
Hmm.
And now we're off to developing second generation, third generation product.
Hmm.
We closed around a large round of funding, so that will enable us to double,
Ah,
triple our sales force, marketing force, and bring us our second generation product. Like if you think about
yeah.
our
Oh,
product line, we developed in the Tesla terms the Model X or the Model
yeah.
S so far, and now we're going to be developing the Model 3
Ah,
to
sweet.
reach more
Oh, the
people.
Model 3.
Yeah.
So it'll be like a lower cost, slightly lower cost, but more accessible and
As any other technology in
ramping
time,
up production.
faster, better, cheaper,
Cheaper. Awesome. That's
smaller.
exciting. So that question that I asked about like changing the data when you upgrade the hardware, that's a fresh one in a
It's
sense.
an ongoing discussion with
Yep.
development.
Ah, I see.
Yeah, yeah.
Gotcha. Where do you see yourselves going in, I don't know, a few years, say 2 to 5 years? Where do you see Alcatraz being?
Well, we definitely want to win over many of the Fortune 1000 companies and then go down market into mid-sized corporations.
Hmm.
We may announce a couple more different products that complement physical access control
Hmm.
on our way to hopefully achieve our dream, which is take over access control,
That'd
take
be
over
awesome.
physical security.
That would be great. What would it would I would love if you guys made I just bought a house and we're doing like smart stuff, so like smart home, like
Yeah.
smart doorbell, smart lock,
Okay.
whatever.
Yeah.
And they are kind of painful to use, even though we got pretty good ones and we have like I don't know. But I would love if you made like a really great door control thing that like did the face recognition and this kind of thing.
Yeah.
But that's probably 10 years down the road or something as you guys take
We'll
over.
see. We'll see. There are many ideas. I personally haven't installed a lock yet on my door. I'm looking forward to installing one this fall.
Hmm.
Uh, but
This fall
yeah, yeah,
on your door for your house, you're saying?
yeah, of course.
Gotcha. That would be awesome. Let's see. So this has been quite a journey for you, I imagine. Like, what advice would you give to yourself at the beginning? Like when you started Alcatraz, for like early founders, what kind of things do you think could like make it easier for them
Strap on very
to be
well.
successful? Strap on.
Strap on very well. It's like a theme park, right? Especially for founders.
Hmm.
It's a lot of downhill, scary moments until you get to the quick seconds of uphill
Yeah.
bliss. um, uh, Everything takes, you hear that all the time, and people may not take it seriously. It takes double the money, double the time, double the effort, double the engineering team.
Hmm.
Uh, Whatever plan you make on day one or on day 365 will change
Hmm.
all the time. So I think the biggest thing that you have to do for the company is to always listen to the customer and create a product that the customers love. Everything else doesn't matter.
Mm. How do you find a product that your customers love, or how do you like how do you get to that?
I mean, if you have an idea, don't start developing on the idea, especially if it involves hardware, like in our case, because it costs a lot of money to
Yeah.
create hardware. Go talk to the people who would buy it and be very detailed on what you want to build. Um, and do small steps. Develop a proof of concept, some kind of prototype, let them test it, then improve based on it. Mm, it's an interesting path if you build something without asking the market whether they want it, and eventually you find out that they don't.
Yeah.
That's a lot of man hours put in to waste. So always listen to the customer on day one
Mm.
before you even start a company.
Yeah. And then backing up a little bit, or just to get your opinion on this, what do you think about the current economy for startups? Like I know it's looking like recession is coming, but like how do you think it'll affect startups or any? What are your thoughts on
Yeah,
this?
it's going to be an interesting 12 to 18 months. Recession is coming. Maybe it's already come.
Hmm.
Based on recent data, uh, startups will have a hard time fundraising.
Hmm.
Only the startups that overachieve will be able to fundraise with no problem. Everyone else, VCs will have, you know, will have will have a hard time justifying an investment because they'll know whatever forecast the startup puts out may not match.
May change heavily.
Early stage startups that are not VC, that are looking for VC money, they're looking for angels, may actually have an easier time because those angels don't have to, don't have a board and LPs with specific restrictions and requirements. They don't have to answer to anyone. It's just their money, and they'll
Mm.
have to think about, okay, do I put my money into the stock market or crypto, which is now not in a great situation. Is it going to keep them going down or not? Do I buy the dip, or actually this is not the dip even?
Or when are we at the
Or
dip? Yeah.
yeah, or do I put my money into a very early stage startup? I'm talking about hundreds of thousands, not tens of millions,
Hmm.
based on the founder vision, and just to get them going. Because many founders may have a great idea. They may need some money to just leave their current companies and just focus on it 24/7. And those are the kind of money that angels, that those are the kind of people that angels support. And I'm not
Hmm.
sure whether the economy, no matter if it's going up and down, will affect those kind of investments.
Yeah, there will
Actually,
still.
nowadays the macroeconomic conditions may help those angels invest in early stage startups or very
Interesting.
very early stage. Like first money in.
Yeah. All right. Wrapping up, any contact info, links, things you'd like to share with our listeners and watchers?
Well, if you want to learn more about Alcatraz, go to alcatraz.ai online. You can always reach me at Vince at alcatraz.ai. Happy to chat, connect you with other people in the company. Um, uh, we we are an AI first company. You can see in our name. It's always been Alcatraz AI, and we're solving some pretty hard problems that I would love to talk about with everyone that's interested. So thank you for the opportunity.
Awesome. Thank you. This was a blast.
Thank you.
Thanks for listening to this conversation with Vince Gaydarzhiev. Thank you again to our founding sponsor, Open Robotics. See you next time.